Hello viewers, welcome to K Diagnostics, Dio here. Today we have a Chevy Express with a 6.0 liter. The complaint on this vehicle is the check engine light remains on while the engine is running. So the first thing we're going to do is we're going to go inside the vehicle and confirm the complaint. After we confirm the complaint, we're going to connect a scan tool to the vehicle to scan the engine computer to see why the check engine light is remaining on while the engine is running. So we're gonna read the codes out of the engine computer. After we retrieve the trouble codes, then we will talk about what directions we're gonna go so we can fix whatever that's causing the check engine light to remain on while the engine is running on this vehicle. So now let's go inside the car and confirm the complaint. So right there, as you can hear, the engine is running and the check engine light remained on. Okay, so right there, check engine light is on. So we have confirmed the complaint. So now I'm gonna turn off the engine. I'm gonna turn the key back on. I'm gonna get the scan tool connected to the vehicle, and then I'll bring you guys back up after I get the scan tool connected. We have 4 trouble codes in the engine computer. The first one is P0442 and it says evaporative emission, evap system small leak detected. Okay, so there's a small leak in the evap system. And then the other one is P1174 fuel trim cylinder balance bank 1 test failed since DTC clear, and it's a history code. And then the other one is P2270 O2 sensor signal stack lean bank 1 sensor 2. So this over here, this trouble code will cause this fuel trim trouble code to be set, because I know on some of these Chevys the computer looks at the signal coming from the sensor after the catalytic converter to adjust the fuel trims. Okay, so this code over here might cause this one to be set. And then the fourth one is P2271 O2 sensor signal stack reach bank 1 sensor 2. So it's the same thing. So I guess this sensor is faulty. The signal on this sensor sometimes sticks lean, and there are times where it sticks rich. Okay, so since the complaint is about the check engine light that's remaining on while the engine is running, what I'm gonna do is I'm gonna focus on these O2 sensor trouble codes first. I'm pretty sure once we find out the problem about this O2 sensor code, this will take care of these 3 trouble codes, and then we're gonna check the evap system to see if there's a small leak. Usually when I see small leak trouble codes, the problem ends up being a gas cap or a gas cap not tightened all the way, so we're gonna check that. But now let's scroll down and see the other codes we have in the other modules. So we have no codes in the transmission control unit. We have 2 codes in the ABS, and over here we have 3 trouble codes in the generic side of the tool. So the OBD2 side, we have the P0442 evap system leak detected, and then this is the lean code, and this one over here is about the sensor O2 sensor signal biased / stack lean. So something is wrong with this O2 sensor on bank 1, so the second O2 sensor on bank 1. Now these O2 sensor codes can be caused by a defective sensor itself or a problem in the wiring between the sensor and the engine computer. So now what I'm gonna do is my next step will be going into the engine computer. Let's go there and let's analyze the data. Okay, let's focus on the O2 sensor trouble code first, and then we will focus on the evap trouble code later. So let's go to data display. Let's go to sensor data. So I want to look at the O2 sensor data and our fuel trim numbers. So we have a bunch of data over here. So now what I want to do is I'm going to customize this list. So we're going to deselect all these data PIDs. So we're going to grab the O2 sensor bank 1 sensor 1, bank 1 sensor 2. So all the O2 sensors, there are 4 of them. I want to look at the heater amperage also. I want to look at how much current these O2 sensor heaters are drawing. Okay, so let's also look at the command and our fuel trim numbers as well. So that's all. So we're gonna list this. So now I'm gonna start the engine so we can analyze the data. So as you can hear, the engine is running. So the command is there. The heater on all the O2 sensors are being commanded on, so that's good. Now the amperage should be kind of the same, okay? The amperage value should be the same on all of them. So over here we have the sensors before the catalytic converter. As you can see, this one, the first sensor on bank 1 is drawing 0.9 amps, okay, 0.88, and so is the one on bank 2. So bank 2 sensor 1 is also drawing 0.82 amps, so right there. And on this side, you know, it's kind of the same as well. O2 sensor bank 1 sensor 2 here, 1 amp, and bank 2 sensor 2 is drawing 1 amp 0.08. So pretty much drawing the same amount of current, which is good. Okay, now the sensor that has a code, that's flagging a code, is this O2 sensor over here, okay, bank 1 sensor 2. So now what I'm gonna do is I'm gonna graph the voltage data PIDs. So I'm gonna graph this one first, bank 1 sensor 2. This is the one that's flagging the code. So we're gonna also graph the one on bank 2. Okay, so this is bank 2 up here, and this over here is bank 1. Now let's graph the first sensors before the cat. So apparently this one over here on bank 2 is sticking. Okay, there are times where it's sticking rich and sometimes it's sticking lean. So now what I'm gonna do is I'm gonna rev up the engine a couple times to see how this one is respond. So we're gonna focus on this one. I'm gonna rev up the engine. So I'm gonna drive them rich by keeping my foot on the gas pedal for a couple minutes here. So our first O2 sensors over here are doing just fine. Okay, now look at the difference between the sensor after the catalytic converter on the first bank and the second bank. Okay, so this one over here, this catalytic converter over here on bank 2 is storing a little bit of oxygen. It's releasing it because the engine RPM is high, and the sensor is seeing that. But look over here, okay? On the bank 1, the second sensor is actually technically stuck rich now. So I'm gonna let off. So they should both be packed rich right now. So this is packed rich, this is packed rich, okay? This one is also packed rich, so that's good. This tells me that the catalytic converters are good, they are working fine. Now let's see how long this is gonna stay rich. And this reading over here is just the absence of oxygen, okay? Not a lot of oxygen is actually getting out of the catalytic converter, because right now, since we were revving up the engine, the catalytic converter is actually storing a lot of the oxygen to actually break any hydrocarbon that might be inside the catalytic converter. Okay, so the absence of oxygen after the catalytic converter will result in a higher voltage, so a voltage of about 7 millivolts or 8 millivolts. Our first O2 sensors are doing just fine. they are basically mirroring each other. So I'm gonna rev up the engine one more time. So let's see. So let's scroll down and look at these amperage readings over here. Look at our fuel trim numbers. So short term bank 1, we are reading between 0 and -2. Okay, and long term bank 1 is 1. So our trim numbers are fine. Okay, so the rule of thumb here is plus or minus 10%, okay, on both banks. And right now we're not even going above 5%, which is good. So this is running fine. I mean, as far as I can see, I don't see a problem here. Now on the amperage side, the one on bank 2, the second O2 sensor on bank 2 is drawing about 1 amp, and the other one is drawing 0.92 amps. So there's a slight difference here, but nothing too crazy. Okay, and our O2 sensors seem to be working just fine. So I drove these sensors rich by increasing the engine RPMs. I was able to have these kind of stuck around 690 or 7 millivolts. So that's good. So now what we're gonna do is I'm gonna create a vacuum leak so we can drive these O2 sensors lean. Okay, I'm gonna drive them lean to see how fast these O2 sensors will respond to a vacuum leak around the intake. Okay, now if this van had a brake system that's vacuum assisted, I was just gonna pump the brakes and that was gonna create a vacuum leak in the intake, which was gonna drive these sensors lean. But this van doesn't have a booster that's vacuum operated. Okay, so what we're gonna do is we're gonna go under the hood and cause a vacuum leak. When we cause a vacuum leak, we're gonna see how fast these O2 sensors will respond. So now let's go under the hood and do that. All right, so we are here under the hood, and this is a small bus, but it has a van front end. You know, I'm not really a fan of working on these vans because everything is so tight over here. So as you guys can see, this one doesn't have a vacuum operated brake booster. Okay, this one is an hydro booster. So now what we're gonna do is we're gonna try to disconnect a line over here that goes to the intake. Okay, any tube that goes to the intake should be disconnected so we can create a vacuum leak. On the scan tool, everything kind of looks pretty good. Now what I'm gonna do is I'm going to disconnect this line over here. This should create a vacuum leak. I heard the engine RPM change a little. So let's look at the scan tool. So as you can see, we created a vacuum leak. Okay, so our O2 sensors have responded. Okay, so this is me creating a vacuum leak at this point. Okay, so they are all responding, but this one is taking a little long. Let me pause this. You see this? So I created a vacuum leak around this area. So as soon as I created a vacuum leak, this one responded immediately. The one on bank 2, okay, the sensor on bank 2, so bank 2 sensor 2 responded. If you look at this number over here at frame 4560, okay, so 4560, and if you look over here, okay, 4560, okay, so the ones before the catalytic converter responded. Okay, these ones responded first. These ones were pretty fast, so they responded first, and then the ones after the catalytic converter responded. But this one responded at, you know, the one on bank 2 at 4,560. Let's look at the one over here. The one on bank 2 responded at frame 4,580. Okay, you can see the discrepancy over here. So this one responded a little bit late. So let me unpause this. And as you can see, even when this one corrected, okay, this one took too long to correct, okay? And this tells me, this kind of justifies why we have that trouble code about this sensor sticking rich and sometimes sticking lean, because it's responding very, very slowly, okay? So it's sticking sometimes. And this is usually caused by a defective sensor. Just now look, you see how this one is dropping out a little bit? And this is normal. This is the catalytic converter storing oxygen and sometimes releasing oxygen, because the catalytic converter only keeps the correct amount of oxygen that it needs to break the hydrocarbon, okay? But right now, you see, it's releasing, and I'm pretty sure the one on bank 1 is doing the same thing, but the sensor over here is just not, I mean, seeing it, okay? It's just not switching fast enough. As you can see right now, it's stuck. So at this point, the signal over here on bank 1 sensor 2 is stuck rich, okay? So this is a problem, guys. This sensor is bad, okay? Now, let's drive this lean again. I'm gonna disconnect this. So we drove it lean, watch. Okay, so we went lean over here. We went lean. Okay. Now they're gonna start compensating. Okay, so it did pretty okay over here. So let's reconnect this tube. So right there, we fixed the lean. So now let's see. Okay guys, this is starting to look like a bad sensor, okay? This sensor is not responding fast enough, so it's sticking, all right? The first sensors before the catalytic converter are good, but this one over here is sticking, okay? It's sticking rich at times, and there are times where it's sticking lean. You see? You see how we have a little bit of activity over here on the one on bank 2, but this one is just stuck. You know, it's stuck at 625. You see how this one is dropping a little bit, but nothing over here. Okay, these two should mirror each other, okay? We have figured out the first problem. This is gonna need a second O2 sensor on bank 1. This sensor is bad, as you can see, it's sticking, okay? We have a flat line here while there's activity on the sensor on bank 2, okay? The second sensor on bank 2, but this one is stuck, so this is the problem. Now what we're gonna do is we're gonna go under the vehicle and get to the sensor and check the wiring. I'm pretty sure this is a conventional narrow band O2 sensor. So it's gonna have 4 wires. 2 wires will be for the heater, and then the other 2 will be for the sensing element inside the O2 sensor. We're gonna check the wiring. If the wiring checks out okay, we will replace this sensor. So this sensor is sticking, okay? It's not responding fast enough. So this sensor is going bad. So let's back out. Remember, we had another code about the Evap system. Okay, so here are our O2 sensor codes. So these O2 sensor codes are causing this P1174 trouble code to be set as well. So now we're gonna check the P0442 trouble code. So we're gonna do this by going out, and we're gonna do a Evap seal test. I mean a system seal test. So let's go to output controls. Actually, let's do the Evap Purge/seal test. So while we're doing this test, we're gonna watch for the vent solenoid, the Evap purge percentage, and the fuel tank pressure sensor data PID. So let's customize this list. I don't want to look at all these PIDs. So let's go to vent solenoid command, Evap purge percentage, fuel tank pressure sensor voltage. So I'm just selecting all the PIDs that will help us figure out where the leak is on this Evap system. These are the only PIDs I want to look at, so let's list these PIDs. So let's open up the purge solenoid first and see. We're gonna watch this voltage over here, okay? The fuel tank pressure sensor voltage. Right now, with the purge valve being at 0%, we are reading 1.1 volts, okay? So now I'm gonna open up the purge. So we're gonna seal that. So when I open the purge solenoid, I mean the purge is opening because the engine RPM changed. Okay, so the engine RPM changing tells me that the purge solenoid is opening. So our fuel tank pressure sensor value is at 1.4 volts. So now I'm gonna open up the purge. So I'm gonna seal it. Our tank value, our fuel tank pressure sensor value barely changed. It's barely changed. This is weird. Let me open this one more time. Okay, I mean it changed. It changed. It went up to 2.7. I mean, I'm watching this fuel tank pressure sensor voltage value over here because with the vent solenoid open, we read 1.5 volts. But when we close the vent solenoid and we open the purge, so we allow vacuum to enter in the Evap system. And when we close the purge solenoid, so vacuum should be trapped inside the Evap system. And as vacuum is trapped in the Evap system, it will drive this voltage over here up, okay, and we will have negative readings over here on the inches of mercury value, okay, because we have vacuum inside the Evap system. So it looks like this fuel tank pressure sensor is responsive. It's responding. Now what I want to do is I'm gonna go inside the vehicle and turn off the engine. After I turn off the engine, I'll tell you what we're gonna do next. So let me go inside the vehicle and turn off the engine. Alright, so let's turn the engine off. Alright, so I did the Evap purge or seal test to check the tank pressure sensor, because sometimes if you have a defective tank pressure sensor, the value on the tank can actually not change or change while it shouldn't. And when the computer looks at the pressure change or the voltage change coming from the sensor, if it's changing all the time, that's kind of how the computer knows that there is a problem in the Evap system, because it watches the signal from the fuel tank pressure sensor. Okay, so if the pressure sensor is sending a skewed signal, the computer will interpret that as a leak in the Evap system. So it looks like this is working pretty well. I'm gonna bring my my smoke machine. We're gonna smoke up this evap system. So our evap service port is right over there. I hope you can see that. So right over there is the service port for the evap system. Let me zoom you guys in so you can see. That green cap you see is the service port of the evap system. So we're gonna remove that cap. After we remove that cap, there is a shredder valve in there that we have to remove so we can inject smoke inside the evap system. Okay, so I'm gonna use my smoke machine to send smoke in the evap system. We're gonna send smoke in the evap system, and then we're gonna close the vent solenoid with the scan tool. After we're sending smoke in the evap system with our vent solenoid in the back closed, the check ball on the smoke machine should drop down to near zero. Okay, that will tell us if the system is sealed or if there's a leak in the system. And as we're sending smoke in the evap system, we're gonna walk around to see if we're gonna find anywhere in the system where smoke will be coming out of. Okay, so I'm gonna go get my smoke machine. I'll bring it over here, and then I'll bring you guys back up after I get it hooked up so we can send smoke in the evap system. So I'm gonna bring the smoke machine and get it set up, and then I'll bring you guys back up. So we're gonna check the evap system really quickly to see if we can find that leak. After we find the leak, we're gonna check the wiring of the O2 sensor to make sure the wiring is good. I'm pretty sure this is just gonna need a O2 sensor. Okay, we're gonna check the wiring, and then we will replace the sensor. Okay, actually before we do that, let's look this up and see where bank 1 is. So we're gonna go to our guided component test. So this is a 6.0 liter. So I want to see my my cylinder layout. So let's go to ignition component. We should have our firing order somewhere over here. If not here, let's see if we can go to, let's back out. Let's see if we have some troubleshooter over here. Yeah, let's go to troubleshooter. Let's go to time saver, engine compartment, cylinder bank layout. Yes. So right over here, it says, so this is the firing order, and then the cylinder layout is driver side bank 1. So cylinder 1, 3, 5, and 7. And then passenger side is bank 2, cylinder 2, 4, 6, and 8. So driver side is bank 1 and passenger side is bank 2. So that's good to know. And our trouble code is telling us that it's the second sensor on bank 2, no, bank 1, that's not working properly. Okay, so right over here, O2 sensor signal stack reach, bank 1, sensor 2. So it's the second sensor on the driver side, okay, because bank 1 is the one on the driver side. All right, so that's good to know. Let me get my smoke machine set up so we can send smoke in the evap system. After we finish doing that, we're gonna go to the O2 sensor. So I'm gonna get the smoke machine set up, and then I'll bring you guys back up. So I got the smoke machine set up and turned on and ready to go. So right now we have smoke coming out of this tube over here. I hope you can see that. So we got smoke right over here. So I did remove the engine cover on the inside so we can get access to the service port on the evap tube. So I'm gonna feed this through. Okay, we're gonna connect this to the evap service port. So right now our smoke machine is on. So I'm gonna grab the scan tool. We're now gonna go inside the vehicle. Okay, so we can connect our supply line of the smoke machine to the service port over here. Okay, so it's a lot easier when you remove the engine cover. So now I'm gonna connect this tube. As you can see, there's smoke over here. So I did remove the shredder valve that goes on the service port over here. So now we're gonna connect this. Okay, just like that. So now we're sending smoke inside the Evap system. So now we're gonna come to the scan tool. So we're gonna close the vent solenoid. So right here. So now when we close the vent solenoid, our Evap system should be, so as you can see right now it's venting, so we're gonna close it. Okay, it's not venting anymore. I heard the click, so our vent solenoid is closed. Actually, let's customize this list. I just want to look at a couple data PIDs. So let's close it. So it's venting, not venting. So we're gonna watch the value on the fuel tank pressure sensor. Okay. Okay, so now we're gonna go under the hood. This is the shredder valve that I removed from the service port of the Evap system. So we got our supply line connected to the Evap system. So now let's go under the hood and look at the smoke machine. Okay, check that out. Okay, so right now the value we have on the fuel tank pressure sensor is 0.2 volts. Okay, and right now our check ball is really down, so this is a good sign, guys. Usually when I see the check ball going down low like this, the problem ends up just being a fuel cap, you know, that's not sealing properly, or that maybe wasn't, you know, turned all the way tight at some point. So let me open this and see what happens. I hope you guys heard a vacuum. As you can see, there's smoke now coming up. If we go to our smoke machine, there will be a big leak on the smoke machine right now. So right now, with the gas cap removed, our check ball went back up, so it went up to the large leak reading. So now let's go back and install the gas cap. It should drop. Okay, and I'm inspecting the seal around the gas cap, and the seal doesn't look bad. Actually, let's look at the reading. I didn't look at the reading on the fuel tank pressure. The fuel tank pressure sensor over here. Fuel tank pressure sensor. So right now, although the vent solenoid is not venting, but we removed the gas cap. So the gas cap is removed. So we are technically venting right now. Okay. And the smoke that the smoke machine is sending is just leaking out. Okay. Now with the system being open, we are reading 1.5 volts on the fuel tank pressure sensor. Okay, so now what I'm gonna do, I mean, we're still sending smoke inside the Evap system, so I'm going to go and reinstall the fuel cap, and then we're gonna come back here and observe this check ball. The check ball should go down if the system is not leaking, and we will also look at this value over here on the fuel tank pressure sensor. Okay, so now let's go and install this fuel cap. As you can see right there, there's smoke. I hope you can see that. There's smoke coming out. So now I'm gonna close this. Okay, so it's closed. No smoke coming out. So let's go back under the hood and check our reading. Oh, check this out. So this is where we put the cap back on. Okay, you see over here. So our value changed. It went down to 0.2 volt. and our check ball over here is decreasing. Okay. Check this out. Let's watch this. So this tells me that our vent solenoid is working well. It's closing the system. Our purge solenoid is also working well, because the purge solenoid is a normally closed solenoid and the vent solenoid is a normally open solenoid. So it's supposed to vent, and then when the computer wants to close it, it closes it and it seals the system when the computer does the evap system check. So right now our check ball went all the way down to the minimum mark, and as you can see here it says evap leak size. So this is kind of the threshold or the normal reading, because there's no such thing as a perfect system. You know, there's always a leak size that's acceptable. Okay, so when the check ball goes down to this point, so that's acceptable. And as you can see, our smoke machine is on. The evap system is good. I don't see a problem in this evap system. Okay, there is no leak. I believe the cap was probably left not tightened all the way at some point. What I can do is I'm gonna recommend a gas cap. You know, although this one over here doesn't look really bad, but I'm just gonna be on the safe side. I don't see a leak. You know, our reading on the scan tool are good. So what I'm gonna do is I'm going to recommend replacing the gas cap, and then we're gonna erase the trouble codes and see what happens. So at this point I'm gonna turn off my smoke machine. Okay, I'm gonna disconnect it. So no leaks on the evap system, and these evap systems can be a pain sometimes. I'm just gonna leave it like that. I'm gonna replace the gas cap and erase the trouble codes, and we will drive it and see what happens. Okay, so we are reading 0.2. Okay, I'm gonna go back and remove the gas cap again, and once I remove the gas cap, oh, check that out. Yeah, this thing is really sealing. This gas cap actually is not bad. You see over here, our voltage just went up. So this over here tells me that our fuel tank pressure sensor is responding, you know, to the pressure change inside the tank. We can either replace this. I mean, it's holding pressure. I don't think this gas cap is bad, but you know what, it's a cheap item. I'm just gonna replace it anyways. So I'm gonna replace the gas cap. We're done with testing the evap system. So now I'm gonna lift up the vehicle so we can test the wiring of the second O2 sensor on bank 1. If the wiring is good, we're gonna replace the sensor. So it's starting to look like this vehicle is gonna need an O2 sensor and a gas cap. We're gonna most likely replace the sensor and install the gas cap. Then we're gonna clear the codes and test drive this and see what happens. So I'm gonna get my smoke machine out of the way. I'm gonna reinstall everything back in the vehicle. I'm gonna reinstall the engine cover, and I'm gonna reinstall the shredder valve that goes into the evap system service port. After I put everything back together, I'm gonna bring you guys back up so we can test the O2 sensor wiring. So I will do that, and then I'll bring you guys back up.